Hello, geometry students. Welcome to lesson 10.6, circles and arcs. So here I just drew a circle that we can reference in looking through the different vocabulary. So what I would suggest is really pausing this video to write down these definitions. Okay, so like I said, I would pause to write down all of these definitions. If I uncover more of these definitions, okay, so again, they all were referencing this circle at the top right here. Okay, so real quick, a circle is a set of points that are all the same distance from a given point called the center. The center is also how you name a circle, so this is considered circle P. A radius is a segment that has one endpoint at the center, so from P, and the other endpoint on the circle. So for example, PC, PA, and PB, those are all radii. Congruent circles are circles that have congruent radii, so they have the same distance for a radius. The diameter is a segment that contains the center of the circle and has both endpoints on the circle. So looking up at this circle here, the diameter is AB. It goes through the center and it goes from one edge to the other. The central angle is an angle whose vertex is the center of the circle. So CPA in this case would be a central angle. A minor arc is smaller than a semicircle, a major arc is greater than a semicircle, and a semicircle is simply half of a circle. Adjacent arcs are arcs of the same circle that have exactly one point in common. And then the circumference is a distance around the outside of a circle, which would be equivalent to like a perimeter in a polygon. Concentric circles are circles that lie in the same plane and have the same center. The arc length is a fraction of a circle's circumference. Okay, so let's get started. Here it says, how is a circle named? By its center. So if we draw a circle and label the center point P, this would be circle P. Before going to the examples, make sure that you understand the vocabulary up through central angle from the previous page. So again, hopefully you've paused and you've written all those down. In this first example, to learn how people really spend their time, a research firm studied the hour-by-hour activities of 3,600 people. The participants were between 18 and 90 years old. Each participant was sent a 24-hour recording sheet every March for 3 years from 2000 to 2002. Okay, so this is how people spent their time between 2000 and 2002. Okay, and here it says, what is the measure in degrees of the central angle used for each part? Well, because we know a circle is 360 degrees, what we can do is we can simply multiply 360 degrees by the percent of that circle. So 31% is the same as 0.31 or 31 hundredths. 20% is the same as 0.20. Remember, when you have a percentage and you want to turn it to a decimal point, you move the decimal twice to the left or you divide it by 100. Okay, so let's get a calculator and let's try multiplying by each percentage. Okay, so this question said, what is the measure in degrees of the central angle used for each part? So again, what we did was we took 360 degrees by the percent of the circle that is used for each part. So when we do that, we get all the different degree angles over here. So there were 1, 2, 3, 4, 5, 6 different sections of this circle. So we have 6 different degree measures. To check our work, what we could do is add these all up, and they should equal 360 degrees. When I checked it, they did indeed add up to 360 degrees. So now we're moving on to an arc. Okay, an arc is just a part of a circle. And so here there's different examples over here. If you go from T to R over to S, okay, that is half of a circle, also known as a semicircle. So the measure of arc TRS is 180. Notice when we measure arcs, we don't use degrees. Here, this is a minor arc. It goes from R to S, and that is less than half of a circle. And so measure of RS is the same as the measure of angle RPS. Here it's saying what is, here we can go measure of RTS, so RTS here. So it's more than half of a circle, but we could find it by taking 360 degrees and subtracting out RS. So how does a major arc and minor arc compare to a semicircle? Well, a semicircle is always half of a circle. So a major arc is greater than a semicircle, and a minor arc is less than a semicircle. So just to reiterate, the measure of a semicircle is 180 degrees because it is half a circle. A circle is 360 degrees. The measure of a minor arc, so something less than a semicircle, is the measure of its corresponding central angle. So the measure of the major arc is 360 minus the smaller arc. So here it says to identify the following in circle O. The minor arcs. So the minor arcs are AD, that's less than half of a circle. CE is also less than half of a circle. AC, this part, is less than half of a circle. And DE is less than half of a circle. Now it asks for the semicircles exactly halfway across. So that means if this is the diameter, you would go from, you could go from one end to the other end. So we could do DAC. So that's this one right here. We could also go DEC, which is this here, or you could say CED. Then we could also think about this line right here. Okay, we would have to go ACE, or you could also do ECA, right? So it doesn't matter, forwards or backwards. Then we could also do ADE or EDA, which is located right here. So in other words, we could also say ADE, because you could go ADE or EDA. So some of these orders, like you could have them reverse, but they're covering the same semicircle. All right, now we're moving on to the major arcs. So these are the things that are bigger than a semicircle. So, and we're looking for the ones that contain point A. So point A, things that are bigger. So we could go from like D to A to C to E. So that would be D, A, E right here. Okay. We could also go, we can't go all the way from A all the way, well actually we could go all the way from A to D. So we could say A to C, E, D. And so we can cover this distance. If we do that, that could be considered A, C, D here. Okay. Then we could go from C, E, D, A. So we got that whole piece, okay, which is noted here by CEA. Or we could also do we could do EDAC. So it's all of this. And that would be noted by this here. So your first and last letter is your starting point and your ending point, and then the middle letter is something in between. I want you to note that 3 letters are always used to name major arcs, and 2 letters are used to name minor arcs. So the 2 letters again at the ends, or the endpoints of the arc, and they can be written in any order. So we can do ACD or we can do DCA. Okay, moving right along, here it says adjacent arcs. They are arcs of the same circle that have exactly 1 point in common. So here says the measure of the arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So here we have measure of arc AB plus the measure of arc BC. If you put those together, you get, these are 2 minor arcs. If you put those together, you then get the measure of arc A, B to C. So it's basically saying you can just add those arcs together to get the larger arc. Okay, so let's take a look. It wants us to find the measure of arc BC. Well, BC is simply the measure of the angle BOC, which is 32, but you don't use a degree symbol. Measure of BD. BD goes between BC and arc CD. So you have to add 32 and 58, and that's how we get to 90. ABC, that is a semicircle. So that is 180 because that would be a 180-degree angle. Last but not least, it's asking us for the minor angle AB. Well, to get this angle here, what we could do is we could take this little, we know AC, A to C would be a straight line or 180 degrees. We can subtract out the 32 degrees and we'd get 148. So the measure of arc AB is 142. Okay, so that completes part 1 of lesson 10.6.